Hello everyone, and thank you for attending today's webinar, Create Stunning 3D Designs and Bring Them to Market Faster. Our presentation today features speakers from Lenovo, Luxion, NVIDIA, and Predator Cycling. Before we begin, we wanted to cover a few items to help familiarize you with the ON24 platform. At the bottom of your screen are multiple application widgets you can use. All the widgets are resizable and movable, and you can expand your slide area or maximize it to full screen. If you have any questions during the webcast, you can submit them through the Q&A widget. Our Q&A moderators are standing by to answer your questions, and we will try to answer them all by the end of the event. A copy of today's slide deck and supporting materials are available in the resource list. We encourage you to download any resources or bookmark any links that you may find useful. You can find additional answers to some common technical issues located in the Help widget at the bottom of your screen. Finally, an on-demand version of the webcast will be available approximately 1 hour after the webcast and can be accessed using the same audience link that was sent to you earlier. Let's begin today's webcast. GPU-accelerated software has revolutionized the design process. Now, organizations can accelerate concept and design iterations, expedite manufacturing processes, and get their products into the hands of consumers faster. In this presentation, we'll explore how designers are creating stunning photorealistic 3D renders of products with ease and in real time with KeyShot. And you'll learn how the unprecedented power and performance of Lenovo ThinkStation desktops and ThinkPad mobile laptops powered with NVIDIA RTX GPUs are enabling KeyShot users to manage these heavy workloads. I'll hand it off to Derek Cicero, VP of Products and Strategy at Luxion, to kick things off.
Hi, I'm Derek Cicero, Vice President of Products at Luxion, the makers of KeyShot. And I want to talk to you today about how visualization has changed over the years and help introduce a new era in visualization, brought to you by the power of NVIDIA, Lenovo, and KeyShot. For those who are not familiar with KeyShot, in its most basic terms, it's a rendering engine that allows you to take your CAD models and create photorealistic imagery with them using ray tracing and global illumination. The more rays we can produce, the more realistic image we can create, and that's where the hardware comes in. KeyShot was first released in 2010. At the time of our initial release, it was the first standalone real-time ray tracing software on the market. But what made us really unique was that we were built from the ground up as a rendering solution for designers. What does that mean? Well, if you ever used a VFX-focused renderer, you know it's a lot of complex settings require a good deal of an investigation to fine-tune for a great image. With KeyShot, we really focused on ease of use, drag and drop for materials, selecting lighting modes based on whether it's a product shot or an interior view, and providing sliders to increase and decrease the settings that align with your needs. We still have all the complex adjustments available in our advanced settings, but our goal has always been to get you to a great image easier and faster. As a result, we've gone from an upstart to an industrial design standard, but along the way, we'd always been CPU-based. But that all changed with the release of KeyShot 9. Luxion had been evaluating GPU rendering for years, but it wasn't until we really dug into the RTX technology provided by NVIDIA that it caused us to go all in with GPU rendering. The performance and the ease of use were simply too great to ignore. With the release of KeyShot 10 this week, we rewrote our costless implementation to take even greater advantage of the RTX technology. So why does all that extra horsepower matter? Well, initially, the KeyShot workflow was very linear and very 2D based. Renderings were often done at the end of a modeling process to either support manufacturing data or provide marketing imagery in the place of photography. And that was a huge win, as it allowed designers to make changes faster and art direct your images in real time. As the use of KeyShot grew and the hardware advanced, visualization became incorporated deeper and deeper into the pre-manufacturing development process, replacing Sketch and Illustrator to provide better decision-making across groups. On the post-manufacturing side, the ability to take a CAD file and output an interactive configurator with its various color, material, and finish options was an enormous time saver. Or to take that same CAD model into VR and see how it looks on a store shelf meant more decision-making possibilities. While we at Luxion provide the visualization tools like 360-degree views, export to AR, and split view animations, the ever-accelerating hardware is what's made it accessible. So while KeyShot started out as a standalone rendering engine, our goal at Luxion has become broader. With these new tools, we strive to help users visualize as much as they can, as early as they can, so they can get to that yes moment of the design faster and easier than ever before. And as you can see from this slide, we have a large and diverse mix of customers that understand the power of great visuals. And there's one thing all those customers have in common, and that's that they expect KeyShot to keep pushing the envelope of performance. As you can see here, the first generation of RTX cards on KeyShot 9 provided incredible results. Our benchmark tool has 1.0 normalized as a Core i7, meaning the RTX 6000 was providing 42 times the performance of our baseline. When we use the second generation RTX A6000 on KeyShot 9, we saw a performance score of 82. So NVIDIA is making tremendous advancements in each generation of the RTX card. When we put the RTX A6000 with KeyShot 10, our latest release, we broke 100. I think this pretty clearly shows the value of our hardware partnerships in providing ever-increasing performance to our users. ARM at Predator Cycling is going to come on in a bit and walk you through just how this performance provides real-world ROI to customers. If you don't already have a GPU-enabled version of KeyShot and want to see how your system compares, you can try the KeyShot benchmark tool. You can download it from free from our website, keyshot.com, and with one click, you can run the benchmark scene and see how your score compares with some of this next-generation technology. Coming up next, we're going to dig into what makes the RTX technology so unique.
Thanks, Derek. We're very proud that KeyShot leverages NVIDIA GPUs to achieve that incredible performance with GPU rendering. Hi, everyone. I'm Don Breda, Strategic Alliance Manager at NVIDIA, responsible for our business partnership with Luxion. NVIDIA is dedicated to pioneering GPU-accelerated computing and solving problems that normal computers cannot. Our platform is installed in several hundred million computers, is available on every cloud and from every server maker, powers many of the top 500 supercomputers in the world, and boasts 1.6 million developers. I'll set the context by talking about two forces shaping computing. For 30 years now, the dynamics of Moore's Law, the principle that the speed and capability of computers can be expected to double every 2 years as the transistors on a microchip increase, has held true. But now CPU scaling is slowing down, while the demand for computing power surges ahead. GPU-accelerated computing is the path forward beyond Moore's Law, delivering 1,000 times computing performance every 10 years to continue to meet the demand for computing power. Next, let's talk about how NVIDIA RTX helps our professional customers meet their computing needs and overcome challenges in their work. What are some of the challenges that professionals are faced with today? Well, for one thing, many large, complex renders can't fit into traditional GPU memory, but it takes a long time to render it on CPU. And what about collaborative extended reality workloads? They're incredibly helpful in allowing us to review our designs in context and at scale, and to evaluate manufacturability and serviceability of those designs, but they require significant visualization capabilities for large projects. We've all heard that accelerated AI tools are coming to help increase our productivity, but how do we democratize access to them beyond just a select few that have AI-capable workstations? And complex, compute-heavy workflows like simulation can help us bring better products to market faster and at lower cost, but they heavily tax a workstation's visualization and compute capabilities. Enter NVIDIA RTX. NVIDIA invented programmable shaders in 2001, opening the way for modern computer graphics. So of course, NVIDIA RTX GPUs have incredibly fast engines for programmable shading to meet your visualization challenges. We call them CUDA cores. But in addition to that, NVIDIA RTX introduces RT cores to accelerate ray tracing workflows and adds tensor cores for artificial intelligence. How do these help to solve our customers' challenges? RTX RT cores greatly accelerated ray tracing, as you saw in Derek's benchmark results, producing photoreal results in real time. And NVIDIA professional GPUs have very large frame buffers to store your complex scenes. NVIDIA's advanced shaders improve VR performance and quality in applications like Luxion's KeyVR Connect, which is currently in public beta. And by the way, KeyVR Connect also leverages NVIDIA's variable rate shading for even greater performance. RTX tensor cores help provide the compute power to accelerate AI-augmented applications like generative design or GPU-accelerated AI denoising for rendering applications like KeyShot. You can get incredibly close to the final ray traced render in 1/10 of the time with denoising. And those CUDA cores, they aren't just for programmable shading. Companies like Ansys use them to pioneer real-time engineering simulation in Ansys Discovery Live so that companies like Predator Cycles can get better, stronger, lighter, and most importantly, faster products to market. I'll run through these next few slides quickly, but I just want you to have a chance to see the NVIDIA RTX GPUs that are available to professionals today. These are the Turing generation desktop cards. They range from the RTX 4000 up through the RTX 8000, scaling in performance as you go. They each have CUDA cores, RT cores, and tensor cores in increasing numbers up through the range. And while the cards on the previous slide have fans for active cooling and are intended for a workstation enclosure, these versions of the RTX 4000 and 8000 are passively cooled for server enclosures. NVIDIA RTX 3000 through 6000 are all available for mobile platforms, each with the same CUDA cores, RT cores, and tensor cores as the applicable workstation and server versions. And at our GPU Technology Conference in October, we announced our first desktop GPU on our new Ampere architecture, the NVIDIA RTX A6000. The A6000 includes improved NVIDIA Ampere CUDA cores, which deliver up to 2 times the throughput of the previous generation, second generation RT cores with up to 2 times throughput of the previous generation. I think you noticed that it was about twice as fast in Derek's KeyShot viewer benchmark. And third generation tensor cores with up to 5 times the throughput. They also have 48 gigs of VRAM, the largest frame buffer for a professional graphics card, and support for PCIe Gen 4 with 2 times the bandwidth of PCIe Gen 3. Chris Rufo from Lenovo is up next to tell you about how you can get these NVIDIA RTX cards and Lenovo workstations.
Thanks for the introduction, Don, and that great overview of NVIDIA RTX technology. I'm going to talk a little bit about what's under the hood of some of Lenovo's most innovative workstations for running KeyShot. In fact, these are some of the same solutions that ARM's using at Predator Cycling to design, style, and visualize their amazing bicycles. Let's have a look. Let's have a look at our new ThinkStation P620. This is the world's first professional workstation based around the PCIe Gen 4 architecture with the AMD Threadripper Pro chipset. It's a perfect host for the NVIDIA RTX A6000 card. It supports up to 128 PCIe lanes. There's 10 gigabit Ethernet on the motherboard. The new fast 8-channel memory, you can have up to a terabyte of 3200 megahertz memory. And it's a perfect host for the A6000, which will allow you to run KeyShot at its maximum speed. Let's have a closer look. Looking under the hood of the ThinkStation P620, we see not only does it take the new NVIDIA RTX A6000 graphics card, but it will also take up to 4 NVIDIA Quadro RTX 4000 cards that will power up to 16 displays. And with the new PCIe Gen 4 architecture, we see transfer speeds of 2x over the previous generation. We recognize that not everyone can have a ThinkStation P620 on their desktop as a supercomputer to run KeyShot, and many users are working remote today, and that's where the ThinkPad P15 comes in. It's a mobile workstation that has desktop power. You can configure it with up to an RTX 5000 graphics card, which will run KeyShot very, very well. The unit's based around the new Intel 8th class CPUs. There's an ultra performance mode that balances how the unit performs when it's plugged in versus when it's on battery mode. Dolby Vision display, Atmos sound, a new 4K touch or non-touch display options with a brand new OLED display. You can configure it with up to 4 terabytes of storage as well. Now let's pop the hood on the P15 and have a look at why this workstation is so powerful. When you have a look at the new architecture, it comes down to the innovative new graphics daughter card board that we've designed that allows for a complete range of configurations. Because the daughter board is removable, we can configure the unit in many, many different CPU and GPU configurations. And the GPU, like I said, will take up to an RTX 5000 graphics board. This also allowed us to reconfigure the heat pipes and fans, so there's bigger fans, more copper that allows the graphics board and the CPU to perform at their highest level. And here is our desktop ThinkStation P-Series workstation portfolio lineup. We talked about the P620 as being the ultimate workstation with the NVIDIA RTX A6000 card for running KeyShot, but we have a full range of desktop workstations for a variety of use cases that range from CAD to CAE engineering to visualization, VR, and rendering. You can find out more about each one of these at lenovo.com. And here is our full lineup of ThinkPad P-Series mobile workstations. We talked about the P15 as the ultimate mobile workstation for running KeyShot. I'd also like to point out the P1, which is our ultimate thin and light workstation for running a variety of CAD applications, KeyShot as well. It's based around the NVIDIA T2000 graphics card, which is a very capable machine for running most CAD applications as well as KeyShot. And last but not least, I'd like to introduce Aram, who's the co-founder and CEO of Predator Cycling, who's going to take you through some of their workflow and how they're using KeyShot. Thank you very much.
Thanks, Chris, for that wonderful introduction. Like Chris said, my name is Aram Goganian, and I am from Predator Cycling. Today, I'm going to talk to you about how we use KeyShot with Lenovo and NVIDIA hardware to accelerate our workflow here at Predator Cycling. To give you a little bit of background here on Predator Cycling, I started Predator Cycling in 2005 with the help of my mom, and we set out with a very clear mission of building the fastest competitive bicycles in the world, period. And we started off like a lot of companies do. We had a cool design, we had a lot of ideas, and we went after it. We started working with some partners, and we started building our first frames. We started testing our frames more. We started bringing more sophisticated CAD. We started simulation. We eventually started moving into composites. And over time, we increased our CAD capacity, our simulation capacity, and brought more and more of that process in-house. Now, fast forward a little bit to 2015, my now wife and I decided to basically pull a rug out from underneath us and reinvent our entire process. We knew that there was inherent flaws in it, and we decided to just start from scratch. And part of that process is what I'm going to be talking to you guys about here on this webinar. So what do we do here at Predator Cycling? We design all of our frames. We do all of our own in-house simulation work, all of our rendering, and all of our manufacturing process is done here in-house. We also manufacture and build and simulate all of our own machinery and equipment that builds all of our bikes. And in a couple of these photos here, you see some of our original RF20 prototypes that we did for stress testing. You also see a CFD render there, and that was done in Discovery Live that uses GPU acceleration to do real-time CFD testing, and a couple parts that we use is using some generative design and some of our CAD modeling. Now let's kind of dive into what we do with KeyShot. So how do we use KeyShot here at Predator Cycling? We use KeyShot to enhance our workflow to present customers with realistic photo renders of their bicycle frames. Because we do so much custom work and all of our bikes are purpose-built for each individual rider, we want to be able to give them an experience where they can see what their bike's going to look like and they can build that emotional connection with their bike really quickly. Now, with KeyShot and our Lenovo and NVIDIA hardware, we can do that so fast, and that's what's really powerful here. KeyShot is a wonderful tool that allows us to be able to use all of our CAD models that we already have and drag and drop all of our finishes, textures, surfaces right onto the part and give a customer a realistic representation of what our bike looks like. So in this slide, we're showing our high-level workflow of how we use KeyShot. So you see here in the image all the way on the left, you see our original sketch where we have all of our hard points drawn out. From there, we basically build out and model our entire frame. And in the past, this is actually where we stopped, and we would show customers this. And it's a great model, it's a great representation of the bike, but it doesn't build that emotional connection with the customer very easily. Now, with KeyShot, we're very easily and very quickly able to produce this render on the right, which allows the customer to imagine what their bike is going to look like a lot better, a lot clearer. Now, one of the really powerful things that happened when we started using KeyShot is we stopped making prototypes for marketing purposes. In the past, we used to make a bicycle frame, and then we'd figure out the paint schemes, and then we would take those paint schemes and put them on a bicycle and paint it, and then photo shoot a bicycle, and then show those to customers and see what they felt. And we had this whole process, and it took us months to do this. Now with KeyShot, we've actually eliminated that because we're able to show customers renders of bikes far before we get to production and even physical prototyping. We can get feedback so much faster. And on top of that, we've skipped that entire prototyping phase for prototyping for marketing, and we go prototyping straight to testing because we've already validated what the bike's going to look like and how the customers are going to respond to that. So it's saved us somewhere between 12 to 16 weeks in our go-to-market timelines, which has been a huge improvement. One of the new things that we were able to introduce with our RF20 was an online bike builder. And this is something new for us. This allowed customers to go on our website and actually play and build their own color schemes for their bicycles and component selections on our site. They can even check out and pre-order the bike on our website. Now, we were able to do all of these colors and all of these renders because of KeyShot. We were able to export transparent PNGs and layer them on top of each other and build this into our shopping cart on our site. So this is a really cool way that we're able to leverage the power of KeyShot for our website. Now, here at Predator Cycling, we use Lenovo workstations with NVIDIA GPUs. And with that combination, we've been seeing tremendous results from not only renders from KeyShots, but also our simulations that we're running and a lot of the design work we do. Our workflows have just accelerated because of it. Now, with KeyShot, it's become a true game changer because with KeyShot's ability to leverage all of our GPU and CPU abilities, we're able to take renders that used to take us hours and sometimes a whole overnight run of renders, we can now do in seconds and minutes. It's a game changer. We're able to now take products that before, are we going to change this color? Are we going to change this lighting setup? And I don't know quite what it's going to look like. Now, instead of waiting 10, 20 minutes to see what that's going to look like in a fully finished render, we now see in seconds what that's going to look like. And that's completely changed how we use all of our tools. I mean, not KeyShots, but also on our simulation side, we're able to run simulations so fast. And it's really just accelerated the process here at Predator Cycling. So here I have a benchmark. Now, as a customer, I see benchmarks, and I'm always a little skeptical about the benchmarks. And so I thought, for full transparency, I would post a benchmark of my workstation running the beta version of KeyShot 10 and show you the results, because this is legitimately my workstation. I have a Lenovo P620 running an RTX A6000, and these are the results off my computer. So I just took a screenshot and posted it up here so you guys can actually see what I'm getting, which is very close to what KeyShots has posted on the previous slide from Derek. And next, I want to show you guys, I want to build a little scenario, and I want to show you an actual workflow that we use here. So I got a little 5-minute walkthrough on a bike render that we're doing. And just to set the scene up, in this scenario, Derek and Dawn and Chris were, chatting, and they decided that they wanted to start a company club, bike club. And so Dawn reached out to me the other day, and he said that he wants to do a club issue bike from NVIDIA and Lenovo and KeyShot. And he wanted some pricing and some information. So we decided that we would do a render for him so that he could see what the bike would look like, and hopefully they all buy new bikes. So we're going to go ahead and jump into just a 5-minute walkthrough on how we do it here at Predator Cycling for a render mock-up of a RF20. All right, guys, we are now inside of KeyShot, and we have our RF20 frame and complete bike loaded into here. So you can see this is a pretty good size model. I mean, this is the full frame that's modeled in. We have our water bottle cages, spokes, all of the cassettes, the chain, crank set. I mean, everything's modeled in. This is a pretty, good size model, quite a bit of complexity here. We are currently running this on our Lenovo P620, and this has the AMD 64-core Threadripper on it. So it is not a slouch by any stretch of the imagination. And we're currently running this in CPU render. So it's handling this very well. I mean, within a couple seconds here, within 5 seconds, we have 22 samples done of the scene. So it's pretty good. I mean, it's quick. Let's go ahead and switch over to GPU mode. We just simply click this GPU button here, and we are now in GPU mode. So you can see that the second I stop moving, it's already sampling, and we're at 5 seconds. We were at about, I think it was 225 samples. So it's a lot faster than the CPU render. So it's very impressive how quick this is. I call this instant. This is real time. And one of the things that makes this really powerful is setting up the models, getting the lighting set up, getting all of my textures set up. It's so quick in GPU that you just click, and you're done. And you can visualize it really well, because I'm not someone that's in KeyShots every single day. I use it a lot, but I'm not in it all the time. So setting up models sometimes gets a little tricky. And with KeyShot being able to be, most of it is all drag and drop and just kind of assemble and put together everything, it makes it really simple, and how fast it is really scary. Now let's go ahead and make the changes to this so that we can send this over to Don and get him to order some bikes. Let's get this green, because that's NVIDIA's color. They love green. So there we go. That was pretty simple. And then let's go ahead and we'll throw back our Predator logo on here for the down tube. Now, these logos, the way I'm doing it is with labels, and they're associated to the material. So when you switch the material, that's why I have to reset this up. And then I'm just going to rotate this around. The other thing that's really been handy that we didn't really notice, we didn't think that we would really use KeyShot for, and is really playing around a lot with our color schemes and graphic kits. Now that we have this GPU acceleration on it, we can really play around with colors more than we had before. And playing around with logo kits and just changing things around all the time because it's just so easy and it's so realistic that it's a great tool just to do mock-ups internally for us. So just brighten this up a little bit. There we go. So there we go. We got our Predator logo put on. I'm going to go ahead and throw on the NVIDIA logo next. So let's go ahead and select that material. I'm going to go in here and just open up this NVIDIA logo. Now these are all simply transparent PNGs I'm using. And this is just really quick. You can see how simple this is to do. So we're able to do this for a customer for simply doing a quote. Because in the past, we would never really do this for customers because it's too much work. It would take me an hour, 2 hours to set this all up, get it, get all the logos set up, get everything in and rendered. It takes a lot of work. So now that we have this set up, we can do this in a matter of minutes. And that really opens up our opportunities for giving customers a better experience. All right, let's set this. Here we go. There we go. Got NVIDIA right there. All right. So there you go. Got NVIDIA's logo put in there, and then we're going to go ahead and I'm just going to fast forward through the next section and do the Lenovo graphics and the KeyShot graphics just for time's sake in the presentation. Now that we've gone ahead and positioned all of our graphics correctly, we can let this sit here for just a little bit and get up to about 500 samples, and then we can take a screenshot and send this over to Don and see what he thinks, and hopefully he wants to buy a bike after this.
I'd like to thank our presenters on this really great presentation about creating stunning 3D designs and bringing them to market faster. We'd now like to move to our Q&A session, so I'll hand it off to Don Breda and Mike Dyer from NVIDIA.
Thanks so much, Brent. Appreciate the help. Let's see. So we have some questions coming in. I'll give the first one over to Chris at Lenovo. Chris, there's a question here asking about what was the motivation for the new graphics daughter card design in the ThinkPad P15? Can you tell us a little more about that?
Yeah, absolutely. That's a great question, Don. I think the motivation was centered around two areas. The first was the daughter card allowed us for greater flexibility in configuration, particularly with certain GPU and CPU combinations. This allows end users like you to be able to configure the P15 to whatever spec you need. The second area was around engineering and management of airflow and heat. It allowed for a new copper piping and fan engineering design in the workstation itself, again allowing that RTX 5000 graphics card to be able to perform at its maximum. Good question, thanks.
Thank you, Chris. That's really interesting, too, because getting that RTX 5000 graphics card into that small form factor is a fantastic feat of technology that the customers will really benefit from. While I have you on, I guess there's another question for Lenovo here, too. I might as well throw that to you at the same time. In the ThinkStation P620, how do GPUs help designers handle larger data sets, renders, and simulation?
No, it's another good question. In fact, I think you did a brilliant job answering around the technology of the RTX cards earlier, around how the technology itself allows for greater compute and to manage different types of workflows, whether it's AI, rendering, simulation, etc. But from our standpoint, in 620, the new PCIe Gen 4 architecture allows us, the overall architecture of the workstation allows us to get the maximum performance out of the graphics board, and in particular the new A6000 card, which will be PCIe Gen 4 compliant. So the combination of the architecture the workstation itself, the graphics board, the CPU, allows us to get the maximum performance out of the GPU. And as we saw earlier, it runs KeyShot like nothing else we've seen.
Yeah, that's a great point. That PCIe Gen 4 bus speed being twice as fast as Gen 3 really lets you take advantage of those large frame buffers that we put into the professional GPUs. So you can store those large scenes, and then you can get the data across between the CPU and the GPU very quickly. That's really, really good stuff. Let's see, we have a few other questions here. How about, oh, here's a good one for Aram. Aram, one of the gentlemen on the phone thinks that your bikes are super sexy and wants to know where you can buy one.
You can, currently the RF20 is for pre-order. We're going to start shipping first quarter of next year, and they're available on our website, photorecycling.com.
Fantastic. So predatorcycling.com. Great. How about one for Derek with regard to KeyShot and Luxion? Derek, what impact did technologies such as ray tracing and AI denoising have on 3D rendering?
Well, it's, the presentation that Aram made kind of really showed, I think, a big part of that, right, which is, and I kind of mentioned this in my presentation as well, is going from this concept of kind of render and wait and having a delay between when you kind of think about what you want to do and you think about some of the concepts you want to do and actually seeing them. And so what we've seen with these new cards, and the denoising is a huge part of that, right? I don't always need a perfect image, right? A lot of times I'm doing look dev, I'm playing with colors, materials, and I really just want to get a sense of, am I going in the right direction? And so what we have found is, people who have these cards with the denoising, you can really just work so much faster and sort of see the results. And then obviously, you can always wait and have it res up fully or do an offline render, but it really allows you to do so much more look dev more efficiently, faster, and really I think kind of, we sort of refer to it as, kind of visualizing at the speed of creativity, right? And so as soon as you can kind of think about it and imagine it, you can see it. And I think for designers, that just really does allow them a lot more flexibility and imagination in what they can come up with.
That's great. Yeah, that being able to see that near final image so quickly is so helpful. And this is a great example of artificial intelligence helping us in workflows that it wouldn't necessarily have occurred to people that artificial intelligence may be beneficial for. I think it's pretty amazing. A lot of people think of artificial intelligence as general AI, but what's a lot more realistic is workflow-specific AI to help us with these specific things. And it really is so great to see that final image or near final image generated so quickly.
Absolutely.
And that kind of leads into this question about for Aram, really. Aram, what's been your customer's initial reaction to seeing these 3D rendered prototypes as opposed to the physical models that had to be painted? I guess the 3D rendered prototypes, they can get exactly what they want much more quickly, huh?
Yeah, so it does that for sure. We can actually show a customer what like a custom paint scheme like we did in this particular example here, but it also opens up the door for us because we can actually engage with customers far earlier on in our product lifecycle. So we're not talking to customers after we've made our first prototype. We're showing customers final paint schemes when we're still conceptually trying to figure it out. And kind of to highlight back to what you were just talking about with like the denoising and acceleration of the renders, I mean, for us, it's a massive benefit because we use KeyShot. I mean, ever since we've been using GPU acceleration, especially with our new stations, we're using KeyShot more because it's quicker, it's faster, we can get images out faster. And like Derek said, you don't always need that perfect final render. I need a visualization. I'm going to, send this to somebody as like a SMS message, just an image so they can see it. And we can do it quick. So, yeah, customers have been loving it since we can engage them so much earlier and show them an actual really nice, high quality shot of what their custom paint scheme is going to look like.
Yeah, that's fantastic. I guess it's it's KeyShot's adoption of that GPU accelerated rendering that really helped you get there. So that kind of raises a question for Derek. Derek, do all versions of KeyShot support GPU rendering?
They do, yeah. So we have KeyShot HD, which is our base package, and then KeyShot Pro. They both support GPU rendering. And as I mentioned at the top, KeyShot 10 was released yesterday, so even greater performance on the GPU from 9 to 10. So we kind of have, a price point for everybody.
No, that's amazing. And so what about materials? Are all the same materials supported for both GPU and CPU? Do you have to switch back and forth when you're using KeyShot to CPU and GPU depending on materials that you're leveraging?
So that was one of the big things that when we integrated GPU rendering, we did not want to do, right? We wanted to make sure that people who were in KeyShot, everything works the same between GPU and CPU. And so they could, drag and drop those materials, their scenes all work. There are, depending on certain things, some slight variations in the rendering. The one material that does not work is the cutaway material, which we're working on implementing. But as you kind of saw from Arm's presentation, everything else, basically, if you use KeyShot on the CPU and you plug the GPU in, you literally just click the GPU button and you're off and running. So there's really no kind of having to, modify or, keep two material libraries inside of that, which is one of the big things that, we knew our customers were going to demand as we added GPU rendering.
Yeah, that makes a lot of sense, and they want to be able to trade their models between each other and not be dependent upon what type of platform they're running the application on, right? So you give them absolute flexibility.
Absolutely, and even to that point, you can be working on the CPU in KeyShot and then send it to our network rendering, send it to a GPU on the network. So if you have RTX cards, out in the office, you can literally send it directly to those cards from, a different machine. So it's a great way to take advantage of GPU rendering from any box.
Wow, I didn't realize that. So if I have a machine that doesn't have an RTX GPU on it, but I want to take advantage of the speed of RTX GPUs in KeyShot, I can set up network rendering on machines that do have it and leverage that. That's really cool.
Yeah, and it's a great way. Like, let's say that you have the RTX on your card, you can make it available at night, so I can throw my renders over to your machine on your RTX card in the evening.
Wow, very cool. Let's see, we have a question here coming in from one of the attendees. CAD files versus designing a product in Maya or similar. What's the best workflow for optimum KeyShot interface? I think he's asking, either CAD files or design in Maya. What would be the best workflow for leveraging KeyShot for visualizing that?
Well, the big thing with KeyShot, which we've, again, done from the beginning, is that we kind of bring in all the files and then really, allow it to be as easy as possible to bring in anything. So we support all the CAD formats. We support Maya. I think for us, our recommendation is kind of, model in the application that you're most proficient in, and we'll kind of take care of the rest once it comes into KeyShot. Generally speaking, with Maya, definitely good for kind of more, organic shapes, and, CAD for more manufacturing. But, from our standpoint, we bring it all in and let you do all the CMF, and, preparation in KeyShot, regardless of kind of what the base application is.
And is there a limit to the number of triangles for GPU versus CPU when using KeyShot?
There is going to be a limit on the GPU side depending on the card, and so that's where you kind of want to understand kind of how what size models you're working with, and base your card selection on that. But certainly what we've seen with the new generation of cards with 24 gigabytes on there, that you can bring some pretty huge models in, and those cards can handle it.
Yeah, that's right. Yeah, that makes a lot of sense. So you're basically limited by the VRAM size on the GPU. You need to be able to fit your scene into that VRAM buffer.
Yes, yeah, and I think on those first gen cards, on the smaller end, you might see some issues, but obviously just increasing at a rate where, again, depending on what you're working on, most scenes come in pretty easily.
Yeah, I think that's, one of the benefits to the Turing generation of the RTX cards is the fact that we have that RTX 8000 that I mentioned. So you've got 48 gigs available there. And then on the Ampere generation A6000, which will be available soon, that's got 48 gigs of VRAM on it as well. So you should be able to fit quite a large scene in there for professional rendering. Let's see, what else do we have here? Well, I got a bunch of questions to read through. Here's one of, somebody picked up on the fact that we were talking about VR, both from the benefit to using NVIDIA GPUs for VR and the fact that Luxion has KeyVR coming out. So maybe this is kind of a broad question generally for the market. So maybe we'll ask our manufacturing marketing expert, Mike. Mike, how are design teams using collaborative VR today, and what options might exist in the future?
Yeah, hey Don, thanks. It's a great question. I think the best example I can give is some of the automotive design studios where I've got friends working. They've actually outfit all of their heads of design with VR workstations in VR, and they're now conducting design reviews remotely in VR. So rather than bringing everybody into the office, they're figuring out, I don't think it's a mastered art just yet, but they're figuring out how to take what used to be a conference room whiteboard, hold a prototype in your hand and look at a clay model process and move that into a VR environment. And we start to think about some of the potential for moving some of the design and surfacing, sketching, markup into VR. It's going to create a pretty exciting paradigm where you kind of go into the matrix of VR to do your design reviews and maybe even some of your design work itself.
Yeah, I think it's really useful. I think one of the most beneficial aspects to it is just being able to visualize things at one-to-one scale and immediately see if you're in the right ballpark with your design, especially human scale type designs like a bicycle.
And so Don,
if
I could piggyback on that comment, talking about KeyVR earlier and kind of how we've worked with NVIDIA to really optimize that is our KeyVR Connect actually allows you to take multi-materials from KeyShot over into KeyVR, so you could actually do a joint session with people in VR and actually scroll through. Let's say you had the bike, you put it in a bike shop, actually scroll through your different colors, materials, and finishes in a collaborative environment. So that's kind of a great example of where our partnership has actually kind of helped lead that into our KeyVR Connect feature.
Yeah, I agree, Derek. I've had the pleasure of getting the opportunity to experience KeyVR in a configurator type environment, and it's so cool to see things at one-to-one scale, real in front of you, and be able to change the colors of them immediately on the fly to get a feel for what the best design is going to be. Really, really cool workflow that enables. Here's one for Aram. It says, Aram, you've done a good job of anticipating where technology trends are heading as you developed your bike. Looking into the same crystal ball, what do you anticipate will make the most impact in how you develop the next generation of bicycles at Predator Cycles?
That's a big question. Yeah, I mean, I think a lot of the stuff that we're experimenting in now is using on the rendering side, we're trying to get renders and our finished parts in front of customers quicker, and to be able to allow them to configure it. Like right now we have our configurator on our website, our bike builder, but we're looking at trying to step that up a little bit more and allow them to modify the bikes, even some of our custom geometry chart and custom modifications more on that side. And then on the bike manufacturing side, we're really focusing on simulation and real-time simulation. I touched on it a little bit in my presentation about how we use ANSYS and Discovery Live and stuff like that. We're using a lot of those tools to kind of push the envelope of what we can do more.
Very cool.
Does that answer it?
We'll have to see if he posts a follow-up. It sounded like it answered it to me. Here's another one. This gentleman is asking about Gravity Sketch VR. He's asking, has anyone used Gravity Sketch VR software, and how KeyShot and how I think it's probably how to KeyShot and NVIDIA/Lenovo interface with it. Is anybody? I'm actually not familiar with Gravity Sketch VR.
I've used Gravity Sketch, and I believe there are export functions, so you could take things out of Gravity Sketch and then bring them into KeyShot for rendering, but I have not actually done it myself.
Here's somebody asking about working with carbon fiber. Aram, your company seems to have mastered the art of carbon fiber based on how beautiful that bike is. Where did you first learn about carbon fiber layout?
I first started doing composite work actually from an automotive setting. So we were working on some automotive projects, and that kind of led us down the path of composites. And yeah, that's where we learned our basic composite structures, and then from there we actually just kind of at Predator we're so self-contained in the sense that like we basically benchmark against ourselves. So we would use a system like a standard like mandrel filament wound wrap tube type system, and then we kept trying to evolve. And so because our benchmark was yesterday, we just kept kind of pushing it. So that's where we got with this new molding system that we're using now for the RF20 and our new line of bikes. But yeah.
That sounds really cool. Next time I'm down in Nashville, I need to come and check out your shop. I definitely want to do that.
Yes,
so
sure.
as we're getting to about 10 minutes before the hour now. I think if we have any final questions coming from the audience, actually we just got one in. This one states that, it just went gray on me. This person has a truck CAD model that consists of about 40,000 components and wants to bring it into KeyShot and show multiple representations and articulations using KeyShot. I've noticed that GPU does not speed that up, CPU does. Can you address this? Any idea what might be going on there, Derek?
Yeah, I assume what he's referring to is actually creating model sets within his different setups, and that's all going to be on the CPU side. So the actual creation or modification of the assets inside of KeyShots with things like model sets and the configurator are all going to be CPU based. It's only when it's pushing out to the actual rendering engine that's going to kick it over to the GPU. And certainly, those are areas where we can look into the future of how we can additionally leverage the GPU inside of KeyShot. But at this stage, it's just focused on the actual rendering engine implementation.
That makes a lot of sense. So really, just when you're calculating the light bounces and ray trace rendering, that's when the GPU gets the real benefit today.
Yeah, and for the gentleman who asked about Gravity Sketch to KeyShot, funny enough, I actually Googled it. Someone last week posted a YouTube video of how to go from Gravity Sketch to KeyShot, and so I included that in there. So for people who also had that question, you can click that link in the Q&A.
Oh, fantastic. What a great resource you are, Derek.
I tried, Don. I tried.
All right. Let's see. Do we have any additional questions coming in? I don't see anything that we haven't answered yet. So I think I'll pass it over to Brent for wrap-up.
Yeah, that sounds great. Thanks, Don. I'd like to again thank all of our presenters from Lenovo, Luxion, NVIDIA, and Predator Cycling. The presentation will be available about 1 hour from now, and we encourage you to interact with our resources list and continue to connect with us. So thank you and have a great day.
Thanks, everybody.